Hello, I'm Dave Smith, an Android dev lead with Double Encore and an Android instructor here at New Circle. Today, I'm going to walk you through the process of building custom views and view groups on Android. As developers, building custom view components is a necessary part of embracing creative UI design. We shouldn't be afraid to implement a designer's unique vision just because the framework, or the community, doesn't provide a component that will do the job for us out of the box. Getting our hands dirty in this area is a great way to build great apps. There are many great advantages to building your own UI components, such as the ability to have full control of how your content is displayed. But one of the best reasons to become an expert at custom view creation is the ability to flatten your view hierarchy. One custom view can be designed to do the job of several nested framework widgets, and the fewer views you have in your hierarchy, the better your application will perform. Our first example will be a simple widget that displays a pair of overlapping image logos with a text element on the right and vertically centered. You might use a widget like this to represent the score of a sports matchup, for example. When we build custom views, there are two primary functions that we must take into consideration: measurement and drawing. Let's have a look at measurement first. Before a view hierarchy can be drawn, the first task of the Android framework is a measurement pass. In this step, all the views in the hierarchy will be measured top-down, meaning measure starts at the root view and trickles through each child view. Each view receives a call to onMeasure when its parent requests that it update its measured size. It is the responsibility of each view to set its own size based on the constraints given by the parent and store those measurements by calling setMeasureDimension. Forgetting to do this will result in an exception. Each view is given two packed int values in onMeasure. These are called measure specs, and they're something that the view should inspect to determine how to set its size. A measure spec is simply a size value with a mode flag encoded into its high order bits. There are three possible values for a spec's mode: unspecified, at most, and exactly. Unspecified tells the view to set its dimensions to any desired size. At most tells the view to set its dimensions to any size less than or equal to the given spec. Exactly tells the view to set its dimensions only to the size given. This is a helper utility here that I often use to quickly size most custom views, as it provides general behavior needed in most situations. It may also be important to provide measurements of what your desired size is, for situations where wrap content will be used to lay out the view. Here is the method we use to compute the desired width for our custom view example. We obtain width values for the three major elements in this view and return the space that will be required to draw the overlapping logos and text. Similarly, here is the method our example uses to compute the desired height value. This is governed completely by the image content, so we don't need to pay attention to the text element when measuring in this direction. Here's a tip to help keep you on the right track. Don't spend time testing and overriding states you don't need. Unlike the framework widgets, your custom view only needs to suit your application's use case. Over-optimizing the code to handle measurement states that will never occur in your application is a waste of time and effort. Place your custom view inside its final layout, inspect the values the framework gives you for measure specs, and then build the measuring code to handle those specific cases. A custom view's other primary job is to draw its content. For this, you are given a blank canvas via the onDraw method. This canvas is sized and positioned according to your measured view, so the origin matches up with the top left of the view bounds. Canvas supports calls to draw shapes, colors, text, bitmaps, and more. Many framework components, such as drawable images and text layouts, even provide their own draw methods to render their contents onto the canvas directly, which is what we have taken advantage of in this example. You may find yourself wanting to provide attributes to your custom view from within the layout XML. We can accomplish this by declaring a stylable block in the project resources. This block must contain all the attributes we would like to read from the layout XML. When possible, it is most efficient to reuse attributes already defined by the framework, as we have done here. We are utilizing existing text and drawable attributes to feed in the content sources and text styling information the view should apply. During view creation, we use obtain styled attributes to extract the values of the attributes named in our stylable block. This method returns a typed array instance, which allows us to retrieve each attribute as the appropriate type, whether it be a drawable, dimension, or color. Don't forget, typed arrays are heavyweight objects, and they should be recycled immediately after all the attributes you need have been extracted. Now that we've seen how easy it is to build our own custom content into a view, what about building a custom layout manager? Widgets like linear layout and relative layout have a lot of code in them to manage child views, so this must be really hard, right? Well, hopefully this next example will convince you that this is not the case. Here we are going to build a view group that lays out all its child views with equal spacing in a 3x3 grid. This same effect could be accomplished by nesting linear layouts inside of linear layouts inside of linear layouts, creating a hierarchy many levels deep. However, with just a little bit of effort, we can drastically flatten that hierarchy into something much more performant. Just as with views, view groups are responsible for measuring themselves. For this example, we are computing the size of the view group using the framework's getDefaultSize method, which essentially returns the size provided by the measure spec in all cases except when an exact size requirement is imposed by the parent. View group has one more job doing measurement though. It must also tell all its child views to measure themselves. We want to have each view take up exactly 1/3 of both the container's height and width. This is done by constructing a new measure spec with the computed fraction of the view size and the mode flag set to exactly. This will notify each child view that they must be measured to exactly the size we are giving them. One method of dispatching these commands is to call measure on every child view. But there are also helper methods inside a view group to simplify this process. In our example here, we are calling measure children, which applies the same spec to every child view. Of course, we are still required to mark our own dimensions as well via setMeasureDimension before returning from this method. After measurement, view groups are also responsible for setting the bounds of their child views through the onLayout callback. With our fixed size grid, this is pretty straightforward. We first determine, based on index, which row and column the view is in. We can then call layout on the child, and we can set its left, right, top, and bottom position values. Notice that inside layout, we can use the getMeasuredWidth and getMeasuredHeight methods on the view as well. These will always be valid at this stage since the measurement pass comes before layout, and this is a handy way to set the bounding box of each child view. Here's another tip. Measurement and layout can be as simple or complex as you make it. It is easy to get lost attempting to handle every possible configuration change that may affect how you lay out child views. Stick to writing code for the cases your application will actually encounter. While view groups don't generally draw any content of their own, there are many situations where this could be useful. There are two helpful instances where we can ask view group to do some drawing. The first is inside of dispatch draw after super has been called. At this stage, child views have already been drawn, and we have an opportunity to do additional drawing on top. In our example, we are leveraging this to draw grid lines over our box views. The second is using the same onDraw callback as we saw before with view. Anything we draw here will be drawn before the child views, and thus will show up underneath them. This can be helpful for drawing any type of dynamic backgrounds or selector states. If you wish to put code into the onDraw of a view group, you must also remember to enable drawing callbacks with setWillNotDraw false. Otherwise, your onDraw method will never be triggered. This is because view groups by default have self-drawing disabled. So back to attributes for a minute. What if the attributes we want to feed into the view don't already exist in the platform, and it would be awkward to try and reuse one for a different purpose? Well, in that case, we can define custom attributes inside of our stylable block. The only difference here is that we must also define the type of data that attribute represents, something we did not need to do for the framework since it already has them predefined. Here, we are defining a dimension and a color attribute to provide the styling for the box's grid lines via XML. Now we can apply these attributes externally in our layouts. Notice that attributes defined in our own application package require a separate namespace that points to our internal APK resources. Notice also that our custom layout behaves no differently than the other layout widgets in the framework. We can simply add child views to it directly through the XML layout file. Just for fun, we will even include the layout inside itself to create the full 9x9 effect that you saw in the earlier screenshot. We have also defined a slightly thicker grid separator to distinguish the major blocks from the minor blocks. I hope that now you can see how simple it is to get started building custom views and layouts. Reduced dependence on the framework widgets leads to better user interfaces and less clutter in your view hierarchy. Your users and your devices will thank you for it. Be sure to visit the GitHub link to find full examples shown here, as well as others to help you get comfortable building custom views. Thanks for your time today, and I hope you learned something new.